When SpaceX's Starship Flight 10 roared to life, it wasn't just another launch, it was a bold experiment, a leap into the unknown. The world watched as the massive rocket thundered skyward, flames billowing and engines screaming, marking another daring chapter in SpaceX's relentless pursuit of innovation. This mission wasn't about perfection, it was about learning at the edge of possibility. Every engineer in mission control knew that success wasn't measured by a flawless flight, but by the lessons hidden in every second of the journey. The team was prepared for surprises, setbacks, and the unexpected. Imagine a crash test, but the car is a 120-meter rocket, and the wall is Earth's atmosphere at 25 times the speed of sound. The stakes are higher, the risks greater, and the data more valuable than ever before. SpaceX wanted to see how much punishment their stainless steel giant could take. The Starship's hull, gleaming and robust, was pushed to its limits, enduring forces and temperatures few materials ever face. Unlike traditional aerospace, which avoids failure at all costs, SpaceX embraces it, pushing systems until they break, then rebuilding stronger. Each test, even the explosive ones, is a step forward, a chance to uncover weaknesses and transform them into strengths. Starship Flight 10 was designed for partial failure. Every second was a data-gathering opportunity. Sensors tracked every vibration, every heat spike, every anomaly, feeding engineers the information they needed to improve the next iteration. The vehicle was uncrewed, flying over the ocean, so risks were calculated. No lives were at stake, only the future of interplanetary travel. This allowed SpaceX to push boundaries that others might shy away from. Engineers weren't just watching, they were learning in real time. Every reaction, every note, every data point was a building block for the next, more advanced Starship. The goal: answer the toughest questions now so future astronauts travel safely to Mars. Every test brings us closer to understanding what it takes to survive and thrive on another world. This was a stress test on a monumental scale, not a routine trip to orbit. The Starship was pushed to its absolute limits, revealing both its vulnerabilities and its incredible potential. SpaceX was conducting a sky-high experiment asking, "How strong are you, really?" The answer would shape the future of space exploration. The answer came in fire, plasma, and resilience. A crucial chapter in our journey to the stars. Each trial by fire forged a better, more capable spacecraft. Each explosive, data-rich test brings us closer to interplanetary travel. Failure isn't the end, it's the fuel for progress, the spark that ignites the next breakthrough. This is how the story of reaching Mars is being written. One fiery gamble, one hard-earned lesson, and one bold step at a time. Re-entering Earth's atmosphere is brutal. Plasma hotter than the sun engulfs the spacecraft. Traditional heat shields burn away or use fragile tiles, but Starship needs something better for rapid reuse. On Flight 10, SpaceX removed many standard tiles, replacing them with experimental metallic tiles and even leaving some steel exposed. Some new tiles had rumored active cooling like a car radiator to draw heat away. By testing multiple solutions at once, SpaceX could see which materials and designs survived the inferno. This experiment is key to building a heat shield tough enough for Mars, and for dozens of flights. As Starship plunged back to Earth, it became a blazing meteor wrapped in plasma, streaking across the sky in a fiery display of human ingenuity and ambition. The sheer violence of re-entry is almost unimaginable, temperatures soaring, air molecules slamming into the hull at hypersonic speeds, and the spacecraft itself glowing like a miniature sun. Cameras streamed the spectacle, heat shield sections glowed, radiating intense energy as they protected the precious cargo inside. Each tile was pushed to its absolute limit, a testament to years of engineering and testing. Flaps fought to keep the rocket stable, slicing through turbulent air, constantly adjusting to maintain the perfect angle and orientation. The hull endured unimaginable stress, flexing and straining as it absorbed the brutal forces of re-entry, every second a battle for survival. The flaps, like a skydiver's fins, made constant micro-adjustments, glowing from the heat. Their movements were precise, each shift calculated to keep Starship on course. Inside, Raptor engines were chilled for landing even as the exterior burned. The contrast was stark, frost forming on pipes just inches from metal hot enough to melt. The challenge: keep systems working under extremes, like freezing an ice cube next to a furnace. Every component had to survive both fire and ice, often at the same time. Flight computers processed torrents of sensor data, holding Starship at max stress to learn as much as possible. Engineers watched every number, every spike, searching for the limits of what was possible. Push too hard, lose the ship, A single miscalculation could mean disaster, scattering years of work across the sky. Not hard enough, learn nothing. The opportunity to advance, to push boundaries, would be wasted. Flight 10 walked that line with precision, balancing risk and reward, and in doing so, brought us one step closer to mastering the most extreme environments in the universe. Live video showed heat shield tiles breaking away, metallic sections glowing, and the steel hull buckling. This was the mission. Find the failure points, collect the data. Suddenly an explosion erupted near the engines, a leak, likely caused by heat and vibration. Yet Starship stayed under control. Flight computers compensated instantly. Flaps kept the ship stable, systems isolated damage, and healthy engines prepped for landing. Despite scars and a blown panel, Starship executed its landing flip and touched down on target. The vehicle was battered, but it completed its mission. It flew, it tested, it landed. That's resilience in action. Starship's survival wasn't luck, it was redundancy. Every system, every backup is there for a reason. In the harsh environment of space, there's no room for error and no second chances. Redundancy is the invisible safety net that keeps missions alive when things go wrong. Like the human body's backups, 2 kidneys, 2 lungs, Starship is built to tolerate failure and keep going. If one system falters, another is ready to take over, ensuring the mission continues. It can land with just 2 of 6 engines. After the explosion, the computer picked the best ones for landing. This quick decision-making is only possible because of built-in redundancies and smart software. Multiple engines, computers, and power systems create a web of backups. If one engine or computer fails, others step in instantly, preventing disaster and keeping the mission on track. Stainless steel makes the rocket tough and repairable, tolerating dents and damage. Unlike fragile materials, it can be patched up in space, giving astronauts a fighting chance if things go wrong. The heat shield's tile system is designed so losing a few tiles isn't catastrophic. The ship can still survive re-entry, even with some damage thanks to this clever design. This toughness and redundancy are essential for Mars, where help is months away. On the Red Planet, self-reliance isn't just helpful, it's a matter of life and death. Systems will fail, the ship and crew must adapt. Redundancy gives astronauts the tools and time to fix problems, instead of facing instant catastrophe. Flight 10 proved SpaceX is building a lifeline, not just a rocket. Every test, every backup, brings us closer to a future where humans can survive and thrive far from Earth. This is how we'll survive the journey to another world. Redundancy isn't just a feature, it's the foundation of our path to Mars and the key to unlocking humanity's future among the stars. Traditional aerospace is slow and cautious. Years of testing, endless simulations, huge costs. SpaceX flips the script: build, fly, break, learn, improve, fast. Failures aren't setbacks, they're data goldmines. Each test flight feeds real-world data into the next design, accelerating progress. Starship Flight 10 didn't just simulate a compromised heat shield, it flew one. This approach only works for uncrewed tests, but by the time humans fly, Starship will be deeply understood. SpaceX's aggressive testing is reshaping the industry and slashing the cost of space. Starship Flight 10 is more than an engineering feat. It's a leap toward making us a multi-planet species. Every lesson from the flight shapes the vehicle that will one day land on Mars. Rapid, real-world testing is the only way to build a robust, self-sufficient spacecraft. Starlink's live video and data links are a game-changer for future missions. While others design, SpaceX flies, fails, and learns, racing ahead. The path to Mars is forged in fire and steel, not perfect simulations. Thanks to bold flights like this, human footprints on Mars are within reach.